Hello and welcome to another video for Further Maths Year 12 EDEXCEL, and today we're talking about chapter 7 of the book, which is about linear transformation. This is after we've finished matrices. And what did we learn in matrices? Finding determinant, obviously normal 4 operations, then finding determinants, finding inverse of the matrix, inverse of 3 by 3 matrix, okay, and then finally solving a system of equations using matrices. Now from here on, guys, what do we need to do? We need to come on to a bit of geometry of matrices. And what do we need to learn? That matrices actually can represent all types of linear transformations, okay, but obviously we work on some specific ones: reflections and rotations using matrices, enlargements and stretches using matrices, coordinates of invariant points, the points which do not change its position after the transformation, and in equations of invariant lines. This is really important topic, the lines which remain the same after a transformation. Carry out successive transformations, then one after the other, reflection and then rotation. Understand the linear transformation in 3 dimensions, that's the planes, okay, and then use inverse of the matrix to reverse the linear transformation. That if you've done something by mistake, like say you reflected, you transformed by something, then how do we invert it, do the opposite of that? Okay, so we will go this chapter section by section. Okay, so every linear transformation we've said that can be represented by a matrix. But first of all, we need to know what is a linear transformation. So in a linear transformation, could be reflection, rotation, enlargement, stretch, okay, and translation, whatever. In any linear transformation, the point 0, 0 always maps on to 0, 0. That means does not change its position. Okay, so this is the first check to see if a transformation is linear or not. If 0, 0 changes its position to a new point, that means it's not linear transformation. Okay, the second check, guys, linear, the word linear tells you we've got to have only the first degree of the variables. That means there should not be any x squares or x cubes or xy terms in it. Right, so the first question we're going to be doing, we got to identify which of the transformations are linear and which of the transformations are not. And if transformations are linear, how do we work out the matrix for them? So we do a few questions in here, people. Okay, so first of all, check if this is question 2b. Check if this matrix, this transformation is linear or not. What I'm going to do, I'm going to substitute x equals 0, y equals 0 over here. So 0, 0 in as column vector goes to 1 and -1. This is non-linear because 0, 0 has changed its position, and we were told that 0, 0 should not, origin does not change its position in linear transformation. Okay, then let's check this one here, people. If I put 0, 0 in here, this is 3c, question number 3c, I get x is 0, y is 0, x is 0, y is 0, so I get 0, 0. So this can be linear transformation, and we can see that there are no powers of the letters involved. So yes, this is a linear transformation. Then, people, this matrix U will be represented by what matrix, this transformation? This is fairly simple. What you have to do is you have to rewrite the matrix in the form of ax plus by and then cx plus dy, and then your matrix will be represented by a, b, c, d. It's very simple. You have to write down x term first and the y term, and then write down the coefficients. Okay, people, in this one, this is 1 minus 1, 1 minus 1. What does that mean? If you multiply this matrix by any point xy, let's prove it, you get that answer. Okay, guys, 1 minus 1, 1 minus 1, multiplied with xy, and you get what? You get 1 times x is x, 1 minus 1 times y is minus y, 1 times x is x, So minus 5, you get to the same result. So this is a linear transformation represented by this matrix. Okay, let's check this one now, people. First of all, check if that's linear. Put in 0, 0, you get 0 plus 0 on the top and 0 at the bottom, which you get 0, 0 again. So yes, it is a linear transformation. Question number 4a. How do we find what matrix represent this transformation? We do what, guys? We just rearrange it in the form of ax plus by. So that's 2x plus 1y and 0x minus 1y. So matrix P is equal to, this is 2, 1 and 0 minus 1. So guys, with that information, you can do question number 1, 2, 3 and 4 of the exercise. You can pause the video, do question number 1, 2 and 3 and 4, and we'll take it from there. Alright, so now we do question number 7 of exercise 7a. It says a rectangle R has vertices. I've tried to draw this on the grid for you. If you can't see, I will show it to you there now, guys. This is the rectangle I've drawn. It says find the vertices of the image of R under the transformation represented by this matrix. So guys, what do we need to do? We have to multiply each of these vertices by this matrix R. Okay, so a matrix this. So guys, I'm going to do that 2, 1. Okay guys, what do? We go in this direction, you know. So minus 1 times 2 is minus 2, 0 times 1 is 0, so plus 0. Second row, 0 times 2 is 2 and minus 1 times minus 1 is minus 1. Okay, minus 1 times 1. So the final answer I get minus 2 and 1. So this is the image of point 2, 1. So point 2, 1, which is here, will go into minus 2, 1. So minus 2, 1. This point, if that was A, that will be the A dash. Okay, so now we find image of all the other 3 vertices as well. And you can do that yourself, guys, and then match the answers with me. Alright, see, so that I did make a mistake in the first one, like I normally do at times, guys. So when you times 0 with 2, it gets 0 minus 1. So this is minus 2 minus 1. So image actually is minus 2 minus 1 is over here. Okay, so these are the other 3 images. So let's do, guys. 4, 1 goes to minus 4 minus 1. So minus 4 minus 1. Okay, 4, 2 goes to minus 4 minus 2. So and 2, 2 goes to minus 2 minus 2, people. So this is the image of the new rectangle. I don't know what do we need to call it. It's called R dash. Okay, right, then next part of the question says describe fully the transformation that maps R into R dash. This is now your common sense of GCSE geometry. What do you think has happened, people? This is rotation about the origin and it is 180 degrees, whichever direction you take. Okay, sometimes people say enlargement by scale factor -1, but obviously which ends up same thing. All right, guys, that's one of the questions of the exercise. So with that information, you can do question number 8, 9, 10 of this exercise 7a, and then we move on to exercise 7b now. All right then, so we're moving on to next 2 sections, which is 7b and 7c. And what do we do in there? We need to find out the matrices which are equivalent to the standard transformations. And guys, what do we do and how do we find that? Is we find the image of the points 0, 0. Obviously linear transformation is invariant. We find the image of 1, 0, then 0, 1, the 2 points 1, 0 and 0, 1. See where do they go, and then write down the matrices on the basis of that. If there is a problem or you have an issue, you can take the third point of the unit square, which is 1, 1 as well. Okay, so let's have a look, guys. The first one we do is reflection in x-axis. I haven't written what it is. Okay, So guys, let's have a look. Let me draw the grid for you. Okay, and we see all the various transformations on this grid, and these are my points 1 1 1 0 and 0 1. Okay, reflection in x-axis, guys. What happens? This point 1 0 stays at 1 0, and this point 0 1 goes on to minus 0 minus 1. Okay, so guys, 1 0 goes on to stays as 1 0, and 0 1 goes on to 0 minus 1. So the matrix for reflection in x-axis will be, we write the image of 1 0 as the first column, so 1 0 stays as 1 0, and 0 1 goes to 0 minus 1. So that is the matrix represented by reflection in x-axis. If at any point you want to check, and we can check now. Okay, let's see, let's pick up a point, people. Point 2 comma 3. Okay, 2 comma 3 would be here. If I reflect this in x-axis, this should go to 2 comma minus 3. Let's see if that works, people. Okay, so we do 1 0 0 minus 1 2 comma 3. Okay, that's 1 times 2 is 2. Make sure I don't make a mistake. 0 times 3 is 0. So 0 times 2 is 0, minus 1 times 3 is minus 3. So 2 comma 3, like we see, is gone on to 2 minus 3. Okay, so this is what this matrix is, which represents reflection in x-axis. Okay, then, so what I want to ask you to do, you're going to do that reflection in y-axis and reflection the lines y equals x yourself, and work out the matrices for them. What you have to do is, you want to see what is the image of point 1 0, that becomes the first column, and what is the image of point 0 1, that becomes the second column. So try that, then match the answer with me once again. These two, reflection in y-axis, reflection in line y equals x. Okay, so this is what I've got. The answer is minus 1 0 and 0 1, and over here this is 0 1 and 1 0, guys, because line y equals x is this. Point 1 0 will be reflected to 0 1, and 0 1 will be reflected to 1 0. Okay, so in this case, reflection in x-axis, people, all the points on the x-axis are, they do not change the position. So invariant line is the x-axis. Okay, reflection in the y-axis, all the points on the y-axis itself will not change its position. So invariant line is y-axis. Okay, so reflection in the line y equals x, all the points on the line itself will not change position. So invariant line is y equals x. Okay, with that information, guys, you're going to be working on to write some few more. Reflection line y equals minus x, rotation about region, angle theta. This is what I'm going to do that with you. So guys, you work this one out first, and then I'll do this next one, next couple of them with you. Right, so let's learn this together, guys. 1 0 on this line y equals minus x will go over here. So guys, 1 0 will go to 0 minus 1, and 0 1 will go to minus 1 0. So 0 1 will go to minus 1 0. So I'm going to write down these images as columns. So 0 minus 1 and minus 1 0 is the matrix which represents the reflection in line y equals minus x, and in that case, guys, the y equals minus x will be the invariant line, because none of the point on this line will change its image. Alright guys, now we move on to a bit of rotation. This is really important that you understand rotation part now. Okay guys, let's try and see what's happening. Rotation about the origin, angle theta anticlockwise. So point 1 0, which is this is 1, will move in the arc of the circle with the radius 1 and this angle as theta. That will be the new position of this point, and this point will also move in that direction anticlockwise. Okay, and with this angle theta in that case. Now guys, we're going to try and find the new positions of these 2 points. Okay, we use our trigonometry to work that out, and we'll work it out with you now. Now try and understand the geometry of this now guys. When this has been turned, so this point, this is 1, okay, this triangle, so this is this over 1 is cos theta, that is 1 cos theta, this line. Hope you understand this. Let me just draw this over here for you guys as a triangle. Okay, if that's theta, this is 1. I want to find this distance. So x over 1 is adjacent over hypotenuse. Car is cos theta. So x equals cos theta. Similarly, the y equals sine theta. Guys, the coordinates of this point becomes cos theta sine theta. Okay, in this triangle, this is important. That has turned, this line has turned anticlockwise by the angle theta. So this is a new triangle formed. Alternate angles, the z angles, guys, this angle becomes theta. I've made this triangle over here to make it bigger. So horizontal distance is now opposite this time, which is the sine. And remember, this is negative as we move from left of the origin. So this point is negative sine theta, or negative 1 sine theta, obviously. And the vertical distance is positive because it's going up. It is cos theta. Okay, so the rotation about origin gives me, I write this as my first column. So this is cos theta sine theta, and write this as my second column, minus sine theta and cos theta. So angle could be anything. If it's 90 degrees, 180 degrees, 270, 45, you just put this into here to find the image of the new points. This is really important that you understand this carefully. Understand that geometry part. Run the video twice and understand it. Now we move on to some of the enlargements there, people. Alright guys, enlargement scale factor 2. So 0.10 from the origin will enlarge and go up to 20. Okay, so that becomes your first column. Right, and 0.1 will go enlarged up to 0.2. That becomes your second column. Scale factor 3 should be the same, goes to 30 and goes to 0.3. And you can clearly see, people, these are the identity matrices when the leading diagonal is times by 2 and this times by 3. So that's his enlargement. So scale factor A should be A, 0, 0, A. And remember, this enlargement is happening in both directions. It is happening in x direction as well, y direction as well. So this unit square with the scale factor 2 will become this. Okay, enlarged in the x direction as well, enlarged in scale factor y direction as well. But what happens if enlargement is going to happen only in one direction? Like for example, this is a square, you just push it that way, so it just gets enlarged in this direction, or just gets enlarged in that direction. They're called stretches, and we're going to be working on 2 of stretches: stretch parallel to x-axis and stretch parallel to y-axis. Think about it. See what the, when it is stretching parallel to x-axis, remember y-axis doesn't change, and when it's stretching parallel to y-axis, remember the x-axis doesn't change. Okay guys, I would ask you to pause the video and work out where the coordinates of 1, 0 and 0, 1 go, and try and write the matrices, then we match it with mine. So in stretch parallel to x-axis, people, what happens, that only the x coordinates gets multiplied by the scale factor and y coordinates do not change. So 1, 0, if it is stretching parallel to x-axis by scale factor A, will go to A0. So that becomes your first column. And 0, 1, because x coordinate is 0 there, 0 times anything stays 0, and y coordinate has to stay the same, stays as 0, 1. Okay, so stretch parallel to y-axis is the other way around. Now only the y coordinates get multiplied. So people, first point 1, 0, x coordinate is 1, stays as 1, and y coordinate is 0. 0 times anything is 0, so stays as 0. Okay, for this point 0, 1, x coordinate is 0, so that will stay as 0. But y coordinate, which is 1, will be multiplied by scale factor A. That becomes 0, guys. So these are the matrices represented by stretch parallel to y-axis. What happens if it is parallel? Sometimes we're going to be doing enlarge or stretch parallel to x-axis by scale factor 3 and parallel to y-axis by scale factor 2. So very important, guys. In this case, a is 3, okay, and this is 2, so that will be 0, 2. Okay, you practice questions, you understand them, guys. Now what type of questions do you want to get? I mean, expectedly you should memorize this, but there's no need of this because you can quickly make a unit square and see where the coordinates of 1, 0 and 0, 1 go, then take it from there, guys. This should take you to exercise 7b and 7c. Okay, practice some questions. I will, in my next video, do some questions of this as well. Okay, so we've finished with this today, and then we make another video for practicing some questions on. Okay, all right. Hello, so like I promised, let's go on to do some questions on exercise 7b. Okay, question number 3. Find the matrices that represent the following rotations. It's 90 clockwise and 90 degrees anti-clockwise about 0, 0. So in the formula which says cos theta sine theta minus sine theta cos theta, put theta equals 90 degrees to find the matrix. Put theta equal all these angles, guys. In this one it says clockwise, so clockwise 135. How much is that anti-clockwise? Will be 360, take away 135, put that angle into there. Okay. Triangle has vertices this, this and this. Find the exact coordinates of the transformation of rotation through 90 degree clockwise. So do the same thing, guys. Put the values of 90 degrees into that matrix, which is cos theta sine theta minus sine theta cos theta. You get a matrix times each of the coordinates with that matrix to find the images. Okay, do similarly this one. Okay, now this question, write down the fully transformation represented by this matrices A and B. So this is the other way around. We've been given a matrix, we want to find the transformation. What do you do is, guys, multiply 1, 0, 0, 1 and see, then draw it on the graph, see where does it go and see what geometrical representation is that. And you can do this now. Okay, let's try and figure that out, this one. So the matrix given to me is 1, 0, 0, minus 1. So I will times 0.10 with this. Okay, guys, what do I get? 1 times 1 is 1, 0 times 0 is 0, that stays as 1. 0 times 1 is 0, minus 1 times 0 stays as 0. So 1, 0 stays as 1, 0. Okay, so 1, 0 stays as 1, 0, and 0, 1 goes to 0, minus 1, 0, 1 goes to 0, minus 1. This is reflection in x-axis. Okay, sorry, 1, 0 stays as 1, 0, and 0, 1 first is 1, 0. This is the image of 0.10 stays over there. This is the image of 0.01 which goes to 0, minus 1. What does that mean? It's reflection in x-axis. Or you can try and figure that out. This point stays, this point comes there, that tells you it's reflection, and so on. Okay, moving on to the next question then. Guys, this is the good one now, number 7. It says write down the fully transformation represented by this. Now this you can clearly see that this is a rotation, because 1 over root 2 would, there will be some angle which gives you this, guys. What do you do in this case then is you substitute cos theta equals minus 1 over root 2 and sine theta is equal to minus 1 over root 2. Okay, when you do your trigonometry in the and over here, guys, sine theta is equal to minus sine theta is equal to this one, 1 over root 2, which gives you same equation, and cos theta same. So guys, these are two equations. You will realize that this, when sine and cos are both negative, this is in this third quadrant. So guys, this should be some rotation bigger than 180 degrees. Okay, put that in the calculator. Theta equals cos inverse of minus 1 over root 2, and sine theta equals sine inverse of minus 1 over root 2 as well. Okay, and you're looking for a chord angle which is in this direction. We'll understand more when you do trigonometry in first year. Okay, right. So question number 8, what does that say here, people? It says describe fully the single transformation representing by the matrix. This same thing again, 1 0 goes to 0 1. So guys, 1 0 goes to 0 1, 0 1, that goes here. Okay, this comes here, and 0 1 goes to 1 0, 0 1 goes to 1 0. Guys, to clearly see this is reflection in line y equals x. Right, moving on then. Exercise 7c, some of it. Let's do question number 7 of exercise 7c. A rectangle has vertices this and this. Rectangles transformed by a stretch with the scale factor 2 parallel to x-axis. What does that mean? Every x coordinate will be times by 2, and stretch with the scale factor -3 parallel to y-axis. Every y coordinate will be times by -3. So guys, this matrix should be 2 0. 1 0 will be represented by 2 0, x coordinate, and 0 -3. So we multiply each of these coordinates with this matrix and find the new image. Okay, we multiply each of this matrix with this matrix and find the new image there. How do I get that? Once again, let me explain that to you. It says scale factor 2 parallel to x-axis. So 1 0 will go to 2 0, x coordinate will be times by 2, and a stretch with scale factor -3 parallel to y-axis, 0 -3. Every y coordinate will be times by -3. Okay, similarly, describe fully single transformation. So this is the identity matrix, with leading diagonal multiplied by 2√5. So that means this is enlargement with scale factor 2√5. And so on, guys. So you're going to be trying all the questions of exercise 7c as well, and then we take it from there. We move on further.